welcome to the Matlax Mathematics Made Simpler. And before we begin the lesson, if you haven't subscribed to the channel, please do so. Okay, so today's lesson we'll be looking at limits. So let's begin. So the limit of a function. So the limit of a function f of x as x approaches the value a is written as this, and is obtained by replacing x by a in the function. Hence, when you are finding the limit of f of x as x approaches a, it literally means finding the image of a under the function f of x. So let's see an example so that you can fully understand what I'm talking about here. So let's see the limit of the function f into bracket x plus 4 as x approaches 3. So this simply means finding the image of 3 under this function. So we are just going to replace x by 3 to get our answer. That is finding the image of 3 under the function. We put 3 here at where we see x, then we get 3 plus 4 giving us 7. Let's look at another example. The limit of f into bracket 2x cubed plus 3x squared plus 5x plus 6 as x approaches 2. It literally means finding the image of 2 under this function. So then we are replacing x by 2 wherever you see x. Then we get our answer to be 44. So the limits of rational functions. A function f of x is said to be rational if it can be expressed as the quotient of two polynomials in x. That is, f of x to be equal to g of x and h of x for h of x which is not equal to 0. Then the limit as x approaches a is given by this. So if you haven't checked out our videos on relations and functions, you can check it out so that maybe you can understand what will be going on in subsequent things. So let's see. So if the value of g of a and h of a are both 0 or at infinity, then the rational function must be reduced or manipulated. The following must be noted. Now, any number with the exception of 0 divided by an infinitely large number is 0. Hence, when you are finding the limit of 4 over x as x approaches infinity, we will have 4 over infinity, which infinity is a very large number. So then our answer is 0. Any number except 0 divided by 0 is infinity. With the same preamble again, when you find the limit of 4 over x as x approaches 0 this time, then we are getting 4 over 0. Now this answer will be at infinity because 0 can divide 4 infinity times. So let's see what's next. Then 0 divided by any number except 0 is 0. Hence, when you are finding the limit of x over 4 as x approaches 0, we'll be getting 0 over 4. It's similar to 4 people sharing 0 apples. No one is getting anything. Okay, let's move on. So let's look at a worked example for finding the limits of rational functions. So now we are finding the limit of x squared minus 4 all on x minus 2 as x approaches 2. What then do we do? Looking at this, when we substitute 2 here from the general rule that we have to substitute x by 2. So when we substitute 2 here, we'll be getting something like this: 2 squared minus 4 all on 2 minus 2. And we'll find out that we'll get 0 for the numerator and also 0 for the denominator. But then but we stated earlier that when the rational function, we are getting 0 for both g of a and h of a, that is the function on top and the function below. We have to manipulate it. So then what do? This is difference of 2 squared, so we separate them to give x minus 2 into bracket x plus 2, and here we can cancel out the x minus 2. Then we continue with our substitution method, then we get our answer to be 4. I guess from this you can try and hands on this one too as well. That is the limit as x approaches 3 of x minus 3 all on x squared minus 5x plus 6. From here you will notice instantly that when you just substitute the 3 here, you get 0 for them, so you have to manipulate it. Let's move on. limit as x approaches infinity. Wow, let's see what the limit is from infinity. Given the rational function f of x to be equal to g of x over h of x, then the limit as x approaches infinity is written as this. And now this limiting value is determined by first dividing through both numerator and denominator by the variable with the highest power of x. Let's see something so we can understand what I'm talking about. So finding the limit of 2x squared minus 3x all on 3x squared minus 2 as x approaches infinity, we are to divide by the highest power of x. We are divide through the numerator and denominator by the highest power of x, and the highest power of x here is x squared. So I have to divide through by x squared, each and every term by x squared. So as I've done here, we are dividing these 2x squared by x squared, and this minus then 3x or x squared as we do here. We can do some cancellations. Then after our cancellations, then we do the substitution as replacing x by infinity. When we replace x by infinity, then from the rule stated, we will know that it will be 2 over 3. So I guess from the examples that we solved, you can try your hands on these questions. And that's all for today's video. Watch out for the video on the limits of trigonometric functions. And don't forget to like the video and also subscribe to the channel. Thank you. See you in the next one.